This is part 1 of statistical analysis, in which we will focus on descriptive statistics and graphs. Now that we've revised all the concepts that you need to know about in order to understand descriptive statistics, we can move on to graphical representations of data. Although I have shown you more than one histogram, I have not formally introduced you to this type of graph. A histogram is a graphical display of data using bars of different heights. In a histogram, each bar depicts a range. Taller bars show that more data points or more observations fall in that range. A histogram displays the shape and spread of continuous data. To construct a histogram from a continuous variable, you first need to split the data into intervals, called bins. In these examples, test scores have been split into bins, with each bin representing a 20-point increase, starting at 0. Each bin contains the number of occurrences, also called the frequency, of scores in the dataset that are contained within that bin. As I mentioned in the previous slide, a histogram can also help you to see if your data is normally distributed. If you connect the bars on your histogram and you observe a bell curve, there is a good chance that your data comes from a normal distribution. Let's test it. If I draw a line on the histogram on the left, like this, a bell curve appears, although granted it's not a perfect bell curve. Nevertheless, this data seems to be normally distributed. In this one, it seems less likely that the data is normally distributed. The number of data points that occur in the lowest bins is too high, and so the data does not fit under a bell curve. Let's move on to a quantile-quantile plot. The QQ plot shows us whether a set of data plausibly came from a theoretical distribution, in other words, from a normal distribution. A QQ plot is a scatter plot created by plotting two sets of quantiles against one another. If both sets of quantiles came from the same distribution, we should see the points forming a line that's roughly straight. A scatter plot is a mathematical diagram that plots two sets of data against each other on an XY graph. By looking at a scatter plot, you can determine the nature of the relationship between two variables. In this example, when the value on the x-axis increases, the value on the y-axis also increases. So, the higher the daily temperature, the higher the number of people visiting the beach. A scatter plot provides an excellent visual representation of the relationship, also known as the correlation, between two variables. When the data points on a scatter plot are close together and form an ascending line, like this, it means that when one variable increases, the other variable also increases. This is known as a positive correlation. When the data points in your scatter plot are close together and form a descending line, like here, it means that when one variable increases, the other variable decreases. This is known as a negative correlation. Finally, when the data points are scattered all over your plot, like here, and don't form a line, it means that there is no correlation between the variables. So, a change in x does not impact y. There are many different types of bar plots, and I'm sure you are familiar with most of them. Bar plots come in very handy when you want to demonstrate the difference between groups on one or more variables. In this example, the difference between grade 3 girls and boys on a range of phonological processing measures is demonstrated. And as you can see, it seems as if the grade 3 girls are doing better than the boys. A box plot, also called a box and whisker plot, is a 5-point summary of the data obtained from a group. Box plots visualize the range and distribution, the central tendency. In the case of the box plot, it's always the median, the quartiles, the interquartile range, and any outliers in your data. This is how you interpret a box plot. The ends of the box are the upper and lower quartiles, so the box spans the interquartile range. This is the interquartile range. The median is marked by a vertical line inside the box. This is the median. The whiskers are the two lines outside the box that extend to the highest and lowest observations. This is the upper whisker. This is the lower whisker. A box plot doesn't show a distribution in as much detail as a histogram, but it is especially useful for indicating whether a distribution is skewed and whether there are potential unusual observations, in other words, outliers. Box and whisker plots are also very useful when a large number of observations are involved and when two or more data sets are being compared. In this example, box plots are used to illustrate group differences before and after a grammar intervention program. Before the intervention, the median was quite similar in both groups. It was around 30 in the control group and just under 40 in the experimental group. The interquartile ranges and the lowest observations are also comparable before the intervention. During the intervention, the experimental group received special grammar instruction to improve their knowledge of parts of speech. The box plots on the right illustrate the performance of the groups after the intervention. The median in the experimental group is now markedly higher than that of the control group. The range in the experimental group is now much smaller, as the lowest observation in this group is much higher than in the control group. From this visual inspection of the data, it would seem that the intervention had a positive effect on the performance of the experimental group. A violin plot shows the same summary statistics as a box plot, but it has the added benefit of also showing the probability density of the data at different values. In a violin plot, the white dot represents the median, the thick bar in the center represents the interquartile range, and the thin line represents the rest of the distribution except for outliers. On each side of the thin line is a kernel density estimation to show the distribution shape of the data. Wider sections represent a higher probability that members of the population will take on a given value, while the skinnier sections represent a lower probability.